in this question, it's saying which of the following statements they have truth value as false. Okay, so they have given us three options here, A, B, and C, and we have to find out which of these will have their truth value as false. Okay? Okay, so let's quickly move on to the solution part. They have given us options over here. Suppose if I consider, let's say my statement A, it's actually a compound statement. You know what is compound statement? It's made up of two small statements, and the connective which you are using here is AND. Clear? Okay. So my A option is actually having two statements. First is 13 is odd. Let me take that as P. Then it's AND in the symbolic form. And then I have another statement that 13 is a prime number. So let me take this as Q. So I have P and Q with me, right? Now, when do I have P and Q as false? Well, there are many cases. Either both of them are false or one of them is false, right? Okay, so let's go back to the truth value of P and Q. So 13 is odd. Well, we know this is definitely true, right? And similarly, 13 is a prime number is also true. And what do we have when we write true and true? Well, true and true definitely is going to give me true. So this statement is having truth value true. So definitely, since they have asked about the false one, A is not the answer. Clear? Okay, moving further. Again, B option, I have my connective and there are two kind of statements. First one is 23 is even. Let me take this as P. And next one is that 23 is a prime number. Let me take this as Q. Right? Now, here, when I find what is the truth value of P, so P is having truth value false because we know 23 is definitely odd number. So this is false. And what about Q? Well, Q is saying that 23 is a prime number, which is definitely true. So that means my Q has truth value true or T. So when I have F and T, what do I get the truth value as? F. That's right. So this is going to have truth value as F. That means B definitely will be one of the right options. Clear? Now we are left with C. We have to just check what the truth value of C is coming out as. Clear, guys? Perfect. So in C again, the connective used is AND. First of all, we have to identify what the connective is being used in the question. Clear? Okay. And then what do we have? Well, first statement is that volume of sphere is 4 by 3 pi r cube. Let me take this as P and I know its truth value is T. It's true because the formula is this only. It's 4 by 3 pi r cube for the volume of sphere. Further, then I have Q as surface area of sphere is 4 pi r square. This we already know, right? And what they have given here is pi r square only. That means my Q statement, which is telling the surface area of sphere is pi r square, is definitely false, right? So now I have T and F, and we know that T and F also is going to give me the truth value as F. So I can say that my right statements are B and C. These both statements will have the truth value as false. Is this clear? A really simple question, isn't it? What do you have to do? First, identify the connective and then accordingly write the truth value of the part of the statements or part of the compound statements P and Q. Clear? Okay, so when we look at the options, we can say that answer will become A. Well, moving on, let's see what they have said here. Consider the following three statements. P is 5 is a prime number. Then Q is 7 is a factor of 192, while R is LCM of 5 and 7 is 35. And they have asked truth value of which of the following four options they have given is true. Okay, so I have to find truth value of all these four options. I have to check for all the four options, isn't it? Perfect. So let's start solving it out. before going to the options, definitely what I have to do first? Well, I have to mark truth value of P, Q and R. Then only I can go with the options, right? Okay, so coming to the statement P, it's saying 5 is a prime number. Definitely you also know that it is true. Coming to Q, 7 is a factor of 192. Is it, guys? Well, no. That means it is false. And the third is LCM of 5 and 7 is definitely 35. So this is true. So these are my truth values of P, Q and R. Now I'll just go by the options and check which of the following is going to give me truth value as true. Clear? Okay. So let's quickly start with my first option, which is A. I have P and Q or negation R, right? Okay, so P and Q, that means I have T and F, or now negation of R is true. So definitely negation of true is going to be false. So this is going to be false. Now tell me one thing, guys. What is T and F? Well, we know the logical connective and we know that T and F is definitely F. So I have F or F, which is going to be F. That means A is not having truth value as true. Clear? Perfect. Coming to the B option. In B option, they have mentioned negation of P and negation of Q and R. Right? Okay, so if P is true, you know that negation of P is false. So it is going to be false. Then I have and. Again, if Q is false, its negation will become true and true. Now, you know true and true definitely is going to be true, right? So I'll have F and T. The value is F. That means B again is not correct. Clear? Quickly coming on to the C option. In C option, it's saying P or negation Q and R. So P is true or negation Q. We have just seen that it's T and T. And you know that T and T is T and T or T again is T. That means C is having truth value as true. This has to be the answer. But on the safe side, guys, do check D option also. So when I write my D option, I'm going to have negation P or Q and R. Now, negation P again is F, right? Or I have Q and R. Now, what is Q and R? Well, that is F and T. And you know F and T is F. So, I have F or F with me, which is definitely F. Clear? Okay, so that means only C option will be the one which is having truth value as true. Have you understood, guys, how you have to solve these kind of questions? Clear? Perfect. And the final answer with us will be C. Well, in this question, they have said, what is the negation of the statement? It is raining and it is school. Okay, so here, what is the logical connective? Well, that is and for sure. And I have two different statements. One is P, that it is raining. And another is Q, that it is school. So that means I have to write negation of this entire part P and Q and then check with the options which are given to me. Understood, guys? Perfect. Let's start with the solution also. So I have P with me, I have Q with me, and I have to find negation of P and Q. Now, guys, what is negation of P and Q? Well, negation of and is going to become or. Similarly, negation of or is going to become and, right? So, negation of P and Q definitely will be broken as it's going to become somewhat like negation of P or negation of Q. First of all, is this clear, guys? Negation of and is or. Negation of or is and. Clear? Okay. Now I have to write this in statement form. So if P says that it is raining, that means negation of Q is going to say that it is not raining. Then I'll use or. And similarly, my negation of Q is going to say that it is not cool, right? So when I write the entire statement, it's going to become the negation as it is not raining or it is not cool. Clear? Have you understood? Perfect. And now if we look at the options, we can definitely say that answer is going to become D. A really simple question, isn't it? Perfect. Well, in this question, they have said which among the following statements are connected by logical, connective, exclusive, or. So first of all, guys, what is exclusive or? Well, exclusive or is, suppose if I have two statements, a statement 1 or statement 2, and my connective is exclusive or, it means either statement 1 will be true or statement 2 will be true, but both they cannot be true simultaneously, right? Okay. Or you can also say is that either statement 1 is going to happen or statement 2 is going to happen, but both cannot happen together. So that is my exclusive or. So I have A, B and C, and I have to obviously write or let's say match with the right options. Okay, so let's start with the solution part. These are the options available to me. So if I go for my option or let's say my statement A, it's saying that integer greater than 1 is prime. That is my P, or let's say my one statement, or integer greater than 1 is composite will be my second statement. Now selection of both together is not going to happen. Either first one is going to occur or the second one is going to occur. So if I have an integer greater than 1 which is prime, can it be composite also simultaneously? No, that is not possible, right? Because any integer greater than 1 will be either prime or composite. That means both they cannot hold together. So this definitely will be my exclusive or. Clear? Okay, perfect. Coming to statement B. What a statement B is saying that sun rises, let's say this is my P, or moon rises is Q. So either my sun is rising or my moon is rising, but both again cannot occur together, right? These two obviously cannot hold together. They cannot be selected together. So definitely my statement B again will be an exclusive or. Clear? Coming on to C option, it's saying, or let's say the C statement, it's saying that you can go through steps or you can go through lift. So one is P, another one is Q. So is this possible? You can go both by steps and lift at the same time? Well, no. Either you'll be going by steps or you'll be going by lift, right? Both cannot hold together at same point of time. That means here again one will be holding true. Or one is going to occur, that definitely means another was not going to occur together at the same time simultaneously. Clear? So this definitely will be the exclusive or. So in all the three statements, A, B and C, what we have used? We have used exclusive or. And have you understood what do you mean by exclusive or? Selection of one excludes the possibility of selection of another. Both of them cannot hold true simultaneously. Both of them cannot occur simultaneously. Clear? Perfect. So if we look at the options, we definitely know answer is going to be D option, A, B and C. I hope you have understood, guys. Well, coming to the question, it's saying that S be the non-empty subset of R, that is real. And there is a statement P which is saying there exists a rational number X which is belong to this set S such that X is greater than 0. So which of the following statements will be the negation of statement P? Okay, so they have given us 4 options here. I have to find negation of the statement P. Clear? Okay. Now, how are we going to do that? Well, P is given to me as there exists a rational number which is greater than 0. What do you mean by this statement? That there is at least one rational number X such that it's positive, right? Now, what is the negation of P? Suppose if I say there is at least one number, so the negation will become there is no rational number which is greater than 0, right? So I can say that negation can be written as there is no rational number x which is belongs to this set S such that x is greater than 0, right? There will be no rational number which will satisfy this property. Okay, further, in what way can we frame this? Well, we can say that if I say there is no rational number greater than 0, I can say that all rational numbers will be what? Less than or equal to 0. That will mean the same thing, right? So I can also say that all rational numbers which are x belonging to this subset, or let's say this set S, such that I can say that they'll satisfy x is less than equal to 0, right? Have you understood? Whenever I say there exists a number which is greater than 0, its negation has to come out as all numbers do not satisfy that property. So I can say that all rational numbers will satisfy x less than equal to 0. Further, I can finally say that my negation of P can be written as for every rational number x, x value is always less than or equal to 0. Have you understood? So what do we infer from this question is, suppose if whenever they ask you about there exists some property, its negation will be for every number or for every member that property is not true, right? So negation of there exists is for all or for every. And it is vice versa also true. Suppose if I say that for every rational number x, x is less than equal to 0, its negation of for every is always there exists a number which does not satisfy this property. So there exists negation will be for all negation will become there exist. Is this clear, guys? Remember this thing. And now if we look at the options, we can say that answer will become B. For every rational number x, I'll have x less than or equal to 0. Is this clear, guys? Have you understood? Perfect.